Hey, Miss Marion here. We are going to do Unit 7, Lesson 1 and 2 today. But what we're going to do is we're going to start having starters that are a little bit different than the workbook. And the reason for this is so that we can go ahead and start reviewing for the end of level test. There's actually 2 of them. So go ahead and get out a piece of paper. In fact, if you want to put this on page 6, that would be great. And go ahead and write all these 4 equations down. Go ahead and solve them on page 6 and then come back to me. All right, let's go through it. Okay, so number 1, what we want to do is we want to get all the variables on one side, letters on the other. I see a subtract 5, so I need to add 5 to both sides. Then we have 6y equals 12. And then 6 and y, they are multiplying, so we are going to divide by 6 on both sides. So then our y is going to equal 2. All right, let's look at number 2. On number 2, again, we want to get variables on one side, numbers on the other. I have a positive 13. I want to go ahead and move that 13 to be on the other side with the 27. So because it's positive, I need to make a negative, or I see a plus, I need to go ahead and do a subtract. So we're going to subtract off 13 from both sides. So we have 7x equals, and then we're going to have 27 minus 13. That is 14. And then again, 14, x and 7, they are multiplying each other. So we are going to divide by 7. So then we have x equals 2. All right, let's look at number 3. With number 3, we have a positive 1. And then we want to go ahead and get variables on one side, numbers on the other. So I'm going to subtract off 1 from both sides. So we're going to have 2r equals 34. And then 2 and r, they are multiplying each other. So we are going to divide by r. And then we have 34 divided by 2. So we have r equals 17. Number 4, again, we want to get variables on one side, numbers on the other. Notice how there's a variable here and a variable here. We actually want to take these variables and put them over here. So I see add 5t to both sides, so I'm going to subtract off 5t. So I have 45 equals, and then 8t minus 5t is 3t. And then 3 and t, they are multiplying each other, so we are going to divide by 3 on each side. 45 divided by 3 is 15. All right, last one. Again, we want to get variables on one side, numbers on the other. So notice how this is a number here, so that means we need to move the number. So I see a subtract 3, so then I'm going to add 3 to both sides. So I have 4p equals 17 plus 3 is 20. 4 and p, they are multiplying, so we are going to divide by 4. So then p is going to equal 5. All right, so this was more just a review, get us our brains going so we're ready for the end of level test that we're going to be doing later this year. All right, let's go ahead and turn to page 125. And we're reading 2 lessons, lesson 1 and lesson 2. Lesson 1 is I can use exponents to describe repeating multiplication. I understand the meaning of a term with an exponent. That is lesson 1. Lesson 2 is I can explain and use a rule for multiplying powers of 10. This is both of our goals for today, so we're actually doing quite a bit for today. Go ahead and write yourself a sentence about how you feel about this lesson, those I can statements for the lessons, and give yourself a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And 4, I can teach it to my friend. All right, let's go ahead and turn to page 7. On page 7, we have these different things, and we're supposed to answer the question, which one doesn't belong. So blank doesn't belong because blank. So go ahead and answer that question, and then come back to me. So we could say that 8 doesn't belong because it's the only one with no exponent. We can say 3 to the second. The one over here, 3 to the second doesn't belong because it's the only one that does not equal to 8. We can say that 2 to the second times 2 to the first doesn't belong because there's two pieces in there. So however you look at it, there's a lot of different reasons as far as different things not belonging. What we're doing is we're actually looking at exponents and we're understanding what things are kind of going along with it. One of the things I do want to go ahead and explain is some terminology. And so let's say we had 2 to the third power. The 3 is known as the exponent. Okay, and then the 2 is known as the base. And so we're going to explain kind of how the base and the exponent, how those work today during this lesson. All right, let's look at page 7 to 8. On page 7 to 8, Maya and Andre, they found an old brass bottle that contained a magic genie. They freed the genie, and it offered them a magical $1 coin as thanks. The magic coin turns into 2 coins on the first day. The 2 coins turn into 4 coins on the second day. And the 4 coins turn into 8 coins on the third day. This doubling pattern continues for 28 days. Maya was trying to calculate how many coins she would have, and remember that instead of writing 1 times 2 times 2 times 2 times 2 times 2 for the number of coins on the 6th day, she could write 2 to the 6th. Okay, so instead of writing 2 times 2 times 2 times 2 times 2 over again, 6th day, you can write it as 2 to the 6th. And yes, there's a typo there. So number 1, the number of coins Maya had on the 28th day is very, very large. Write an expression to represent this number without computing its value. And number 2, Andre's coin lost their magic on the 25th day, so Maya has a lot more coins than Andre does. And how many more coins does she have than Andre? Go ahead and answer these 2 questions, and then come back to me and we'll talk about that. All right, so as we kind of looked up here, the 2 times 2 times 2 times 2 times 2 is same, and it was the 6th day, right? And it was 2 to the 6th. So let's use that same pattern of what she did before, but we're doing to the 28th day. So we're going to say 2 to the 28th. Okay? And then let's talk about Andre and Maya. So this is Maya, right? And Andre, he had 2 to the 25th power. So how much more is Maya's than Andre? So let's kind of think about it. So Andre pretty much has 25 days. She has 28 days. So let's talk about how much more. Well, she would have 2 times 2 times 2 because she has 3 more than the other. So she has, and if we multiply all that together, she has 8 more coins. Okay, so if you didn't understand that, go ahead and pause, rewind it, and then go back through it again so you understand what we actually just barely did. So what we're going to do is we're going to kind of watch an applet. So as far as kind of like exponents and how they work and how they what they look like if we were putting the coins on like a piece of paper. So that was showing, again, kind of what we just barely experienced, how they're, with exponents, it just gets bigger and bigger and bigger over the time. Let's go ahead and turn to page 78. So let's kind of go back to the genie kind of information itself. And notice how I kind of put everything into a table. And notice how we have 2, and it's 2 to the first, the value is 2. Then we have 2 times 2 times 2 times 2. It's 2 to the 4th. So 1, 2, 3, 4. So the exponent is 4. But the base, or what is being repeated over and over and over again, is 2. And then it's 16 is the actual value. So the base, what is repeated over and over again? 1, 2, 3, 4, 5, 6. So 2 is being repeated 6 times. And the value is 64. So let's kind of think about it. How many times larger is 2 to the 6th than 2 to the 4th? And how does expanding into factors help you see this? Go ahead and pause this. Go ahead and answer that question and then come back to me. All right, so let's think about it. So 2 to the 6th, there's 6 2's. 2 to the 4th, there are 4 2's. So how much bigger is it? So it is 2 times 2, which is 2 to the 2nd, or 4 if we multiply that together. And so for me, expanding it out actually helps me understand a little bit better what's going on as far as what it is, because we can have it as 2, 2. Well, let's actually do a little better. Let's erase that. Okay. So 2 to the 6th is 2, 2, 3, 4, 5, 6. And then we have 2 to the 4th. 1, 2, 3, 4. And then we can see that there's 2 more extra with the 2 to the 6th compared to the 2 to the 4th. All right, so let's go ahead and turn to page 8 to 9, and we're going to talk about the broken coin. So after a while, Jada picks up a coin and sees different than the others. She knows that the next day, only half of the coin is left. So on the second day, there's only a fourth of the coin left. On the third day, it's an eighth of the coin that remains. What fraction of the coin remains after 6 days? What fraction of the coin remains after 28 days? Write it as expression with an exponent, okay? And does the coin disappear completely? If so, how many days? Go ahead and answer those questions and then come back to me. All right, so let's figure out the fraction after the 6th day. So if we use what we just learned earlier about the coins, not the broken coins, but the normal coins. So remember that the coins that we're dealing with right now, it goes halfway, right? So we're going to have it as 1/2 raised to the 6th power. What does that mean? We're going to have 1/2 times 1/2 times 1/2 times 1/2 times 1/2. 1, 2, 3, 4, 5 times 1/2. Okay? And we actually want to find out what that actually is. So if we multiply all the ones together, it's going to be 1, right? And then we're going to go ahead and, so it's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 times 2 is 64. So the value of it is 1/64. So let's kind of talk about the 28. So if we want to write it as 28 days, we are going to have 1/2, and all of that is going to be raised to the 28. So does the coin disappear? Honestly, the coin will never completely disappear, because each time it just gets a half smaller and a half smaller and a half smaller and a half smaller. Now, it gets really, 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 really small, but it does not completely go away. And so we're going to watch a video about that. So notice how it gets smaller and smaller, 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 but it's never ever going to go away. All right, so let's kind of go over what we kind of talked about so far for today. What is 2 to the 42th power? It's 2 being repeated over and over and over again 42 times. How many times larger is 42 to the 45th than 2 to the 42nd? Well, there's 3 more here than there are here. So of 2s, it's going to be 2 times 2 times 2, which is 8. What does it mean when I write 1/2 to the 42nd time? That is 1/2 being written down, multiplied together 42 times. And then which one is greater? 1/2 to the 42nd or 1/2 to the 45th? With fractions, it's a little bit backwards. 1/2 to the 42nd is actually going to be bigger than 1/2 to the 45th. All right, let's go ahead and turn to page 13, and let's look at this box that we have. Claire says she sees 100. Tyler says he sees 1. Maya says she sees 1 over 100. Who do you agree with? Go ahead and write that down on this page and then come back to me. So looking at all of these, it really depends on how you're looking at it. Everyone is actually correct. So we can see this whole thing as like one big hole, right? So that's Tyler. If we count how many tiny little boxes are inside, there's 100. And we can say that we have 1 of 100. So it's one big hole of 100. So everyone is actually correct. It depends on how we're looking at it and what we want to pick apart and see. So on page 14, we have this diagram. It says, in the diagram, the medium rectangle is made up of 10 smaller squares. The larger square is made up of 10 medium rectangles. How could we represent the large square as a power of 10? And then if each small square represents 10 to the second, then what does the large square represent? So we're just going to do numbers 1 and 2 together first, and then we'll go ahead and talk about the rest of them. So we can actually represent the larger square as 10 to the second. Because if we look at it, we have 10 smaller little squares kind of going side to side, and then we have 10 squares going up and down. So it's 10 to the second. And then if each small square represents 10 to the second, what would the larger be? So we know that we have 10 to the second as what it represents, and then each one is 10 to the second. So how many 10s do I have? Well, I have 2 10s here. I have 2 10s there. So pretty much I have 4 10s written over and over again. And I can write that as 10, the base being repeated over and over again. And how many do I have? 4. If the medium rectangle represents 10 to the 5th, what does the large one represent? So let's kind of change it just a little bit and see what happens from there. All right, so if the medium square represents 10 to the 5th, what does the larger square represent? So we know that each square, the medium square, is 10 to the 5th, and then we have 10 of those inside the larger one, so then this is going to be 10 to the 6th. And then what would happen, so also we need to figure out with the smaller one, what happens, right? So this one was larger square, and then let's put the smaller in, so small square, let's put it in blue. Okay, and so we think of the smaller one as, well, we have 10 to the 5th, okay, so that is the whole entire medium one, and there's 10 of those, but we have to make it smaller, so we have to divide by 10, and so then it will be 10 to the 4th, because we have 5 10s on the top, 1 10s on the bottom, and if we multiply, if we kind of do 10 divided by 10, it's 1, and it kind of subtracts it off. And then let's look at number 4. If the large square represents 10 to the 100, then what does the medium represent? And then what would the smaller one represent? Let's talk about the medium first. So we're going to have 10 to the 100, and we're going to divide it by 10, and that's going to be 10 to the 99. Okay, so there's 110s on the top, 1 on the bottom. And then we know how if we do 10 divided by 10, we cross it out and make a 1. Same kind of thing here. Then what about the smaller one? Okay, so we want to look at the smaller one itself. So we're going to have 10. So we're going to have 10 to the 100. And we're going to divide that by 10 to the second. And the reason for that is because we have pretty much like 110 here, and then like here, and then we have to do it again here. So what would the answer for the smaller one be? Well, that's going to be 10 to the 98th power. All right, so let's start filling in this table. And we can skip one of the single boxes, but let's go ahead and let's talk about powers of 10 and what it's going to go ahead and look at. So go ahead and fill this in, and then tell me which one you feel like you need to skip. And then come back to me. All right, so let's go ahead and do this. So we have 4 10s in the front. So 1, 2, 3, 4. Sorry. I don't have my pen today, so I'm doing it with my finger. There are 3 in the back. 1, 2, 3. What is the number being repeated over and over again? It is 10. And let's count how many we have. 1, 2, 3, 4, 5, 6, 7. So we're going to have it as 10 to the 7th power. Okay, so let's do it again. We have 4 10s in the front. So we're going to have it as 1, 2, 3, 4. And then we have 4 10s in the back. 1, 2, 3, 4. What number is being repeated over and over again? That is 10. How many are there? We can count them. Oh, there's 8. So it's going to be 10 to the 8th. All right, let's kind of do it backwards. So how many 10s do we have here? Well, that's 3. So we're going to have 10 to the 3rd. And then how many 10s do I have here? 1, 2, 3, 4, 5. Okay, that's going to be 10 to the 5th. And then it's 10 being repeated over and over again. And how many times is it repeated? 1, 2, 3, 4, 5, 6, 7, 8. So then it will be 10 to raise to the 8th power. I'm going to decide to go ahead and skip this box. I'm going to kind of follow the same pattern as far as what's going on here. And I'm going to go ahead and say that this last box is going to be 10 to the 41st power. And the reason for that is I have 18 in this first one, 23 in this second one. We were adding them all together so that it was 10 to the 41. All right, so let's go ahead and answer number 2. So I went ahead and put all the table there with everything that's in it. And it says, use the pattern you found in the table to rewrite 10 to the n times 10 to the m as an equivalent expression with a single exponent like 10 to the, and these question marks should actually be up here. Okay, so we're going to write it kind of all together. What were we doing? So go ahead and pause, enter that, and then come back to me. So my expression that I'm going to write down is 10, and we're going to do n plus m. So let's go ahead and try that. So if I go 2 plus 3, that was 5. 4 plus 3, that is 7. 4 plus 4, that is 8. 3 plus 5, that is 8. So notice how that works. And I forgot to type in the rest of this number 2. It says if you had a rule, so let's go ahead and use our rule for 10 to the 4th times 10 to the 0. So if you use this rule, what is it going to be? It's going to be 10 to the 4th, right? So what does this really mean as far as the 10 to the 0 power? And then 10 to the 0 power, it's actually a definition. Anything raised to the 0 power is actually 1. So really what it's saying is 10 to the 4th times 1 equals 10 to the 4th. So again, anything raised to the 0 power is 1. All right, so let's go ahead and answer the question. The state of Georgia has roughly 10 to the 7 human residents. Each human has roughly about 10 to the 13th bacteria cells in her digestive tract. And then how many bacteria cells are there in the state of Georgia? So go ahead and answer that question. So pause and answer that question, and then come back to me and we'll talk about it. All right, so let's kind of think about it. So we have 10 to the 7 humans. We're going to multiply that by 10 to the 13th because each person has 10 to 13 bacteria. And so if we go ahead and do this, we use the rule that we just barely found out. We're going to have 10 is repeated over and over again to the 20th power, which is really huge number, but that's how much bacteria there is in Georgia. All right, so let's kind of think about it again. What did we talk about? How can we write 10 to the 15th and 10 to the 5th? Being multiplied as a single exponent, we add those exponents together, so we'd have 10 to the 20th. And then what is a rule for multiplying 2 powers of 10 together in a single power? Okay, so kind of like the same thing itself. Go back to page 125, read the I can statements for lesson 1. I can use exponents to describe repeating multiplication, and I understand the meaning of a term with an exponent. Also read number 2. I can explain and use a rule for multiplying powers of 10. So go ahead and write yourself a sentence for those I can statements, how you feel about today. Give yourself a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach to my friend. And make sure you do practice problems. We are doing 2 practice problems today. lesson 1 and lesson 2. Hope you have a good day. Bye.